friends, and welcome to YouTube channel Freedom Tech. And in this session what we are going to learn? In this session we are going to configure esp8266 Wi-Fi card, which basically control with the help of hand gesture using opencv and CV zone on Raspbian Buster legacy version 32-bit. Okay, so before we move to our practical friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much, and let's get started. So friends, I have already created the video, the demo video, so we can control the esp8266 Wi-Fi card with the help of opencv and CV zone. Okay, so concept is what? We need to install the opencv, TensorFlow Lite, CV zone and media pipe first on our Raspbian Buster legacy version. This is what the basic modules. Okay, then for esp8266 we are going to configure the MicroPython on our esp8266. Okay, then MQTT broker, we are going to configure our Raspberry Pi 4 as a MQTT broker server. Okay, so when we show our hands to our Raspberry Pi 4 with the help of CV zone, it will detect our, it will basically track our hands. Okay, then suppose if I show the one finger up to the Raspberry Pi 4, so our Raspberry Pi 4 will be send the message on our esp8266. Okay, when we show fingers up or down. Okay, so this is the concept. So we are going to see all these things step by step. So for that, as I told you, first you need to install opencv, then media pipe, then TensorFlow Lite, then CV zone on Raspbian Buster legacy. I have already created the video. I will mention the video link. Watch video and install all these basic modules first on Buster. Okay, then I have here my Raspberry Pi 4 camera module, which I have connected with the Raspberry Pi 4. If you don't know how to configure the camera module with the Raspberry Pi 4, I have already created a video. I will mention the link. Watch video and configure the camera module with the Raspberry Pi 4. Of course, you can use the USB camera for this project also. Okay, so I have already done with basic modules, and I have connect the camera module to the Raspberry Pi 4. For today's session, I have created here a repository. So repository name is hand gesture Wi-Fi card. Okay, I will mention the link. You need to simply copy the link, then open the link inside the browser, then go to the code and copy link, and of course we are going to start with cloning our repository. So open terminal, run the command sudo git clone, and we need to paste our link. Just hit enter, it will clone our repository. Okay, so it's cloning. So we have successfully downloaded our folder, or we can say our repository. So first we need to change the owner. So because when we download the repository, it's belong to root user, so we need to change the owner and the group with pi user. So sudo chown space hyphen capital R space pi is the user colon pi is the group space, and mention the repository name which we just download, hand gesture Wi-Fi card. Okay, so this is what the command for changing the owner. Okay, so we are done with changing the owner. Now what we want to do, first we need to download our MicroPython firmware. Okay, so open the folder from file manager. This is what our folder, hand gesture Wi-Fi card. Open it, and inside that I have created a firmware txt simple text file. Right click, text editor, and this is what the link, the official link for downloading the MicroPython firmware. Open the browser, not terminal, browser, and new tab and paste link and just hit enter. It will open the micropython.org firmware official website. Okay, so latest, which is the first one, version 1.18, this is the latest firmware. Okay, so we need to simply click on the link and it will download our firmware. Okay, so we have successfully downloaded our firmware. I am going to close the text file, and we need to go inside the downloads. As you can see, this is what our firmware, the .py. Okay, so we have done with the downloading our MicroPython firmware. Now what we want to do, we want to connect our esp8266 with the Raspberry Pi 4 USB port. Okay, with the help of normal USB data cable. So connect the ESP8266 with the Raspberry Pi 4 USB port. So I have connect the ESP8266 with the Raspberry Pi 4. Then go to the here menu programming Tony Python IDE, and first we need to install the ESP tool on our Raspberry Pi 4. So tools, manage packages, and here we are going to search for ESP tool. Okay, click on search on PyPy. It will automatically search the package. The first one is the ESP tool. This is what our package. Click on the package, and as you can see I have already installed, that's why it says uninstall. So you need to simply click on here, click on the install. It will automatically install the ESP tool on our Buster. Close. Okay, then what we want to do, we have now done with installing ESP tool package. Now go to the run, select interpreter. Here we need to select the MicroPython ESP8266. As you can see, MicroPython ESP8266, select it and try to detect port automatically, means it will detect our port, our ESP8266 port automatically. Okay, so then we need to click on install or update firmware. Okay, and click on port. As you can see, it's detect the port automatically. So CP2102 USB UART bridge controller, this is what our ESP8266. So suppose if you have the ESP8266 with CH340, then of course it will show here a CH340. Okay, so right now my ESP8266 is basically with a CP2102 chip, that's why it says here CP2102. Okay, so then we need to select our firmware. So click on browse, and I have my firmware inside the downloads folder. As you can see, click on OK. Then here we need to select the flash mode dual IO DIO, and erase flash before installing is automatically selected. Simply click on install. As you can see, it's now installing 3%, so it will take a little bit time. So it's now installing our firmware on our ESP8266. Okay, so friends, as you can see, it says done. It means we have successfully installed our MicroPython firmware on our ESP8266. Simply close, click on OK. Okay, and then as you can see, if you see here, ESP module with ESP8266 MicroPython version 1.18 means it's now open our MicroPython shell, means we have successfully done with installing our firmware inside our ESP8266. That's it. Now as I told you, we need our files. So go to the file, click on open, and right now we have our repository which we have downloaded. Right now the repository inside our computer. So we need to select this computer, and we need to select our folder. So our folder is basically inside the Pi, not downloads, Pi, and this is what our folder. As you can see, hand gesture Wi-Fi card, which we have just closed, and we need to open the co.py. Click on OK. co.py, close the untitled co.py. Then again go to the file, click on open. Same this computer. Okay, our hand gesture Wi-Fi card. Then we need here our sub.py. Click on sub.py and just click on OK, and it will open the sub.py. Then again go to the file, click on open this computer, and same folder, hand gesture Wi-Fi card, and we need here this time our main.py. Click on OK. Okay, so co.py, first what we want to do, we have these files inside our Raspberry Pi 4. So we need to save this file inside our MicroPython ESP8266. So we need to select all these files. So we are going to start with co.py, go to the file, click on save as, and this time we are going to save inside the MicroPython device with same name. So MicroPython device, and mention the same name. So co.py will co.py, click on OK. Then sub.py, go to the file, same procedure, click on save as, MicroPython device, and sub.py, click on OK, and then go to the file again, click on save as, and sorry, I forgot to select a file. The main.py is now file, so select the main.py and go to the file, click on save as and MicroPython device, and the name same, the main.py. Okay, that's it, click on OK. So we have now saved the file inside our ESP8266. So we are going to start with the first one file, which is the co.py. co.py is basically connection.py, which basically connect our esp8266 with our router. Okay, so this is what the network file. So I have created a function, and here you need to mention, as you can see, wlan.connect. Here you need to mention your router ID. So I have mentioned my router ID Valorant, and you need to mention here the Freedom Web Tech. You need to mention here your router password. So here SSID means your router name, the SSID, and here your router password. Okay, that's it. Now then you need to simply click on run, and it will connect the ESP82. It will basically run the script, and our router will be assigned the IP address for our ESP8266. As you can see, network config and 192.168.0.104. this is what my ESP8266 now IP address. Okay, so we have now done with connecting our ESP8266 with our router. Then sub.py. So sub.py is what? Sub.py is our main program file, which basically control our DC motor, which basically our subscriber. Okay, so when our Raspberry Pi 4 will be publish the message, the ESP8266 will basically our subscriber. It will subscribe for particular topic, and it will receive the message from our Raspberry Pi 4. Okay, so for that I have to mention here from umqtt.simple import MQTT client. This is what our module. Okay, then import machine, then from time import sleep. Okay, then server. So server is basically our Raspberry Pi 4 IP address. So if I open my Raspberry Pi 4 terminal, if I run the command if config and hit enter, as you can see, the 192.168.0.23, this is what the Raspberry Pi 4 WLAN IP address, the Wi-Fi IP address, which I have mentioned here. As you can see, 192.168.0.23. So remember one thing, friends, here you need to create the static IP address for your Raspberry Pi 4 WLAN. Okay, because next time when you start the Raspberry Pi 4, of course the Raspberry Pi 4 Wi-Fi address will be changed, because the Raspberry Pi 4 Wi-Fi is basically connect with your router, and router always change the DHCP range. So you need to create here a static IP address. I have already created a video how to configure the static IP address for Raspberry Pi 4. So I will mention the video link. Watch video and first configure the static IP address for your Raspberry Pi 4. So this is what my static IP address will basically not change. Whenever I start the Raspberry Pi 4, this IP address will remain same. Okay, so this is what our MQTT broker server IP address means, our Raspberry Pi 4 WLAN IP address, which we want to mention over here. I hope so far so good. Then we need to create a variable. So C is just a variable, then MQTT client. Okay, this one, because we import the umqtt.simple from, we import the MQTT client, so we need to mention that over here, MQTT client, and inside that we need to mention umqtt_client, and we need to mention our server. So server is basically this variable. This variable is basically our IP address of our Raspberry Pi 4. That's it. I hope you are clear. Then P is basically machine.pwm, because we are going to control the DC motor with PWM. So we need to mention machine.pwm, then machine.pin. So this is what our connection with ESP8266 and our L29A10 DC motor driver board. Okay, so P is equal to machine.pwm, machine.pin, the 5 number, then machine.pwm, machine.pin 4th one, then machine.pwm, machine.pin 12, and machine.pwm, machine.pin 13, then LED. So I have created here our onboard LED is basically signal for getting the idea, the communication is going or not. Okay, so LED is equal to machine.pin. This is what our onboard LED pin number, the 16, and machine.pin out. Okay, so I will show you the diagram. So this is just for idea what basically we have inside our sub.py. That's it. So this is basically our connectivity. This is basically our connectivity with L29A10 and our ESP8266, and this is what our onboard LED pin. This is what our onboard ESP8266 LED. The pin number is 1660. That's it. Then define the message function is basically receiving the message from our Raspberry Pi 4. So message AB data str string format B UTF-8, it will print the data. Then if 1 in data, okay, means our Raspberry Pi 4 will be send the 1. Then for I in range 600, then P dot duty 0, P1 dot duty I, P2 dot duty I. This is the I. The range we are going to set here 600, 0 to 600. This is the PWM range. Okay. Then P2 dot duty I, P3 dot duty 0. Then same way for 2. Then same way for 3. Then the goodbye is basically stopping the action of our DC motor. Okay, that's it. Then this is what the client. This is what our connectivity. This is basically creating the connection between our server and our ESP8266. So C dot set callback MSG. So MSG is our function which we have create here. As you can see, this one, the MSG, we need to mention here. And C, what is C? So C is basically our server. As you can see, we mentioned here C variable. So C is basically our server and all the information. So we need to create like this way. C dot set callback, C dot connect, C dot subscribe. This is what our topic. This is what our topic, which basically ESP8266 subscribe. So test 2, C dot wait message, check message, and it will disconnect. Then while loop, LED dot value 0, sleep 0.5 milliseconds, LED dot value 1, sleep again 0.5, and we need to call our client function. So client function is here, client. That's it. Then the main.py. So main.py is file for running our co.py and sub.py. When we start our ESP8266 next time, we want to automatically run our co.py and subscribe.py. So we need to create here a main.py file, and inside that we need to call our co.py and sub.py. So inside that main.py, I have input here, import co. Co is basically our co.py file, and import sub is basically our sub.py file. That's it. I hope you all clear. Now what we want to do, we want to simply go again here, file, click on open MicroPython device, and we need to open the boot.py. Okay, and inside the boot.py we need to call our main.py. So here we need to mention import main. That's it. It means the next time ESP8266 boot, it will automatically run main.py, and of course it will automatically run co.py and sub.py, because inside the main.py we call our co.py and sub.py file. Okay, so we need to save our main.py file inside our boot.py. So simply save it. That's it. Now we have all the done with our ESP8266 side. Now we need to move on our Raspberry Pi 4 again. So I am going to minimize our Tony Python IDE, and here what we want to do, as I told you, we need to configure our Raspberry Pi 4 as a MQTT broker. Okay, the server. Okay, so how to do this? Simply opening, we need to open our repository again, which we have cloned. So hand gesture Wi-Fi card, this is what our repository, and inside that, as you can see, mosquito broker and client.txt. Open the text file, just a minute. Okay, so it's automatic open with the text editor. So inside that I have mentioned all the commands for configuring our Raspberry Pi 4 as a mosquito broker server. Okay, so you need to simply copy all these commands. So we are going to start with the first one. Copy it, copy the command, open terminal, and let me first clear the screen. Paste, just hit enter. It will install this package. I have already installed the package. Okay, so then we need to enable our service. So second one command, copy it, copy, open terminal and paste, and just hit enter. It will enable our service. Okay, then we need to edit the etc mosquito.conf. So this is the command sudo nano. We are going to use the nano editor. So simply copy the command, copy it, open terminal and just paste and just hit enter. It will open the mosquito.conf and come to the end, at the end. And here you need to copy these two lines. These two lines you need to simply copy it and paste at the end. As you can see, I have already copied listener space 1883 and allow anonymous true. So you need to copy these two lines at the end of the file, the mosquito.conf. As you can see, I have paste at the end. Then Control X, Y, enter and save the file. Okay. Then you need to simply reboot your Raspberry Pi 4. Okay. So just reboot it, and whenever you start your Raspberry Pi 4, you need to start your Mosquito broker server backend. For that, we need to run this one command. So copy the command, open terminal. After reboot, you need to copy and paste mosquito space -d command. This will run your brokers the server backend. Okay. So now we have our server ready. Now what we want to do, we want to test our server. So we need to copy this one command, copy it, okay, and open terminal again. Let me clear the screen, and what we are going to do, we are going to open again new terminal. This one is second terminal, edit, zoom in, okay, and the first command, this is the command, first one, the subscriber side, copy it and open terminal, paste and just hit enter. Okay. So this is what our subscriber, and another terminal, this is the second terminal. Okay. And here you need to mention the publisher command. So copy it, it will publish the hello world message. As you can see, I have mentioned the hello world. So just copy it, copy, and which terminal, okay, this is what our subscriber, so this one is our publisher terminal. Just paste and hit enter. If all is good, on publisher side, on the subscriber side, you will see the hello world message. It means we have successfully configured our Mosquito server, Mosquito broker server. Okay. So we have done with making our Raspberry Pi 4 as our server, our own server. Okay. So now what we want to do, close all these things. So we want to now our main file, which is the hand.py. So we need to open this hand.py from our Raspberry Pi 4, because we open our esp8266 MicroPython inside our Thony. So we can't open same time our Python 3. Our Python editor. Okay, so we need to open for testing purpose. We need to open our hand.py from our terminal. So I am going to open the terminal. I am going to clear the screen, and here we need to command cd space hand gesture. This is what our repository, hand gesture Wi-Fi car, and ls command, and this is what our hand.py file which we want to run with the help of terminal. So sudo python 3 hand.py. If I hit enter, it will open, it will start our live frame. Okay, and as you can see, this is what our live frame. If I show a hand to the camera, it's detected my hand, and if you see here, it's printed right now. As you can see, it says the 5 finger is up, 555. Now as you can see, 4444, because the 4 finger up. Now the 2 finger, so it says the 22222. Now the 1 finger, as you can see, 111111. Okay, so this the counting which we are going to use as our if condition. Okay, so if the one finger is up, it will send the message the 1. Okay, so this is how we are going to use the count for sending the message. Okay, so now simply press escape. Like this way, we need to click on the frame, and then we need to press escape. It will close our live frame. Okay, from the terminal. Okay, so now we have done with all the things on our Raspberry Pi 4 side, on our ESP8266 side. Now inside the hands gesture Wi-Fi car, I have here the image, hand car image. Click on image viewer. I have mentioned here pins also. So as you can see, I have mentioned here a pins and the wire colors and the ESP8266 pins and the L29810 driver board pins. So D2, the green color wire, so this one is the green wire. So D2 green color wire connect with the iron 1 of L29810 D2. Then D1 the blue color wire, okay, blue color wire, iron 2, as you can see the D1, the ESP8266 D1 pin which we want to connect with the L29810 DC motor driver board pin iron 2, okay. Then the ESP8266 D7 the orange color wire, okay, this one orange color, okay, orange color wire, D7 orange color wire which we want to connect with the L29810 board pin iron 4, and the D6 of our ESP8266 board pin D6 the wire color yellow. So D6 pin which we want to connect with the L29810 motor driver board iron 3 pin, okay. So D2 iron 1, D1 iron 2, D7 iron 4 and D6 iron 3. This is how we need to connect the ESP8266 board with L29810 DC motor driver board pins, with the DC motor driver board pins, okay. So now the 9 volt battery. So battery plus means the live connection, the battery plus connection which we want to connect with the L29810 board, the first port, this one, the first port, okay. The live connection, the red wire, as you can see the red wire, first port, and same time ESP8266 the Win pin, okay. So I have here also the ESP8266 pins diagram. As you can see, the ESP8266 has the Win pin, the first one, VIN Win. This pin basically we can use for powering our ESP8266, okay. So Win pin also we want to connect with our L29810 board, okay. So this is what our L29810. So as you can see, the battery live, the live connection connect with the first port of our L29810, and same time the Win pin of our ESP8266 we want to connect with the same port where we connect our battery plus connection, or we can say battery live connection, okay. So Win pin wire connect with the first port, then the battery ground which we want to connect with the second port, and same time the ESP8266 ground, because the ESP8266 has many ground. So this one is the ground, this one is the ground, we need to choose any one of the ground, okay. And the ground which we want to connect with L29810 second port, which is the ground port where we connect the battery ground, okay. So in simple language, the red wire which is the plus wire connect with the first port, same time the ESP8266 Win wire connect with the first port, then the battery ground connect with the second port, same time ESP8266 ground also connect with the second port. Then the DC motor you can connect any wire, whether here it is or here it is also, okay. So connect the DC motor wires for first port and the second DC motor for second port. Here also same things, first port, second motor, second port, okay. So this is the diagram, okay. I have mentioned the pins. I hope this will give you a better idea how to connect the hardware with the L29810 DC motor driver port. So we have done with the hardware setup, we have done with the software side. Now what we want to do? Now we are going to see the practical, okay. So now I am going to start my mobile camera, and first we are going to see the practical mode, Okay. So friends, as you can see, this is what our car chassis, L2910 DC motor driver board, the esp8266, and right now I have powered the esp8266 with the help of Raspberry Pi 4 because we are going to see the code test. Okay, so I am not powering esp8266 with the battery. As you can see, this is the battery live connection which we are going to connect with esp8266 after complete our test. So remember one thing, do not connect the both power connection with esp8266. So as you can see, this is the battery plus connection. I have not connected with Win pin because we are powering our esp8266 right now with the help of data cable. Okay, and this is what our jumper cables, as you can see, this is what our jumper cables which I have connected with our L2910 DC motor driver board as I mentioned in the diagram. Okay, so now we are going to first test our code. So this is what our Tony Python IDE, and this is what our scripts which I have already explained, the co.py, the sub.py, main.py and boot.py. Okay, so connection co.py. So I am going to start first co.py. Let me run the code. Now it's connect with my router 192.168.0.104. This is what the IP address is right now assigned for our esp8266, and this is what our sub.py. Okay, so we need to start our sub.py. So I'm going to run the sub.py. Now we need to run our hand.py from our terminal. So this is what our folder, as you can see, the folder name is hand gesture Wi-Fi car, and here we need to run python 3. Let me run the command sudo space python 3 and our script name which is the hand.py. Okay, and enter. It will start the live frame. As you can see, it started the live frame and onboard LED is blinking. It means our communication in between esp8266 and our Raspberry Pi 4 is perfectly going. That's why it's blinking the LED. Okay, but right now there is no hands. Okay, so that's why the car is not moving, there is no action. Okay, so if I show hand, 5 finger is up. Okay, 5 finger is up. Now 1 finger is up. As you can see, the wheels are moving. This is what our the forward action. This is what forward action. If I show 1 finger up, the car will be moved forward. Now 5 finger is up, stop. 2 finger is up. As you can see, 2 finger is up. It's now reverse mode. If I 5 finger is up, it's stop. So right now there is no hands, the car is stopped. It means our software, or basically we can say our code is perfect working and our hardware is perfectly connected. Okay, so our project is perfect completed. Now we are going to see the demo. Means we are going to see we are going to basically disconnect our esp8266 with the Raspberry Pi 4, and now I am going to connect this battery plus connection with the Win, and we are going to see our car in action. Okay, so friends, as you can see, the frame is started and right now there is no hands, so car is stopped. Okay, so we are going to start with showing 5 finger is up, car is stopped. Okay, so if I show 1 finger up, car is moving forward. 5 finger is up, stop. Okay, if I show 2 finger up, car will be moved backward. Again stop, 5 finger is up. 5 finger is up. Okay, so again if I show 1 finger up, it will move forward. As you can see, stop, 2 finger up, backward. If I want to move left, so I just want to show here 3 finger up. As you can see,
3 finger up, 3 finger up, again 2 finger up, again 3 finger is up, 2 finger up, it will move backward. Okay, so there is no fingers, it will stop the car. Okay, so this is how you can control the car, the esp8266 Wi-Fi car, with the help of CV zone and MQTT server. I hope you will learn something from this video. We will meet our next video. Till then, thank you, take care, and bye bye.